Hi, now we will discuss the concept merge sort in this session. How to solve merge sort using divide and conquer algorithm design technique we will discuss in this session. In design and analysis of algorithms, there are five algorithm design techniques. Among those, divide and conquer is one of the algorithm design techniques. When we are applying divide and conquer technique to some of the applications are, if you consider the given problem is complex problem, in this case, we need to solve the problem very easily within a span of less time. We use the principle of divide and conquer algorithm design technique. When we apply divide and conquer algorithm design technique to the given complex problem, the problem is to be divided into two number of subparts. And again, we can apply the same procedure till all the elements in the given problem are small problems. Then we go for apply, conquer it, and combine it. Finally, we will get the solution to the original problem. So, in this case, in this way, we can solve the solution to the given problem by using divide and conquer technique. In this lecture, we will discuss how to write divide and conquer algorithm and how to solve merge sort algorithm and how to write merge sort algorithm and how to find and how to solve merge sort problem and finding or analyzing the complexity of merge sort. These three concepts we will discuss in this lecture. Now let us discuss the concept as how to write merge sort algorithm. So before writing merge sort algorithm, let me tell you the concept behind the merge sort technique. So merge sort is one of the sorting technique. It is an algorithm which can follow key concepts, namely the first one is divide, conquer, and combine. When we apply divide and conquer technique to the merge sort, first we can do divide, conquer, and combine. So the main idea behind the merge sort is to sort the elements in the given array within a less number of sorted type. Now consider an array. The name of array is A. The array can contain n number of elements. Here, if you want to arrange the n number of elements in the array in a sorted order, there are three ways you need to follow. So whenever you are planning to sort the elements in the given array A, you need to apply one technique that is called divide and conquer technique. This is the principle we can apply for merge sort algorithm. When we apply divide and conquer principle to the given sorting algorithm, so we need to follow three steps. The first one is divide. When we apply divide to the given problem, the array is to be divided into two number of equal sub-arrays. After that, we need to conquer it. Conquer means sorting the two sub-arrays recursively by using merge sort concepts. Once the elements are sorted, then we need to combine the sub-arrays in the form of a single final array, which can be the original solution, the solution to the original problem. So in this way, we can solve the merge sort problems very easily or quickly with the help of divide and conquer algorithm design technique. Now here we will discuss how to write merge sort algorithm. An algorithm is a step-by-step procedure to provide or to solve the problem is known as an algorithm. Here we will learn how to write an algorithm for merge sort. So before writing an algorithm, now we will see an example here. Consider an array. The array size is 8. The size of an array is 8. There are 8 elements which are placed in the array. The elements are not sorted here initially. The elements which are placed in the given array is randomly we can place it. So in this case, we need to find or we need to sort the elements in a ascending order by using merge sort. How that can be, how the process will do, we will learn in this session. So here, the first element, sorry, in the array is considered as P. The last element in the array is considered as R. And we need to find the mid element. How to find the mid element is mid element equal to first element plus last element by 2. Here the first element array index is 1. The last element array index is 8. 8 plus 1 by 2. 9 by 2, 4.5. Here in this case 4. A of 4 is considered as the mid point, mid element. So now here we noted P is considered as the first array index value and R is the last array index value and Q is to be considered as a mid value in the given array. Once we can find the mid value, then we will see how to write an algorithm. So we can consider why we need to divide why we need to divide the array into two sub-arrays. We can consider the given array is a complex array. If you feel that the given array is a complex array, you need to apply the principle as merge sort, divide and conquer principle to the merge sort. When we apply the divide and conquer principle to the given merge sort algorithm, the array is to be divided into two number of equal subparts like this only. So here, always the array, always whenever we are planning to write an algorithm, so the header part of an algorithm is algorithm merge sort. Merge sort is the name of the algorithm. And here we are passing three parameter list, namely A. A is considered as array and P is the first array index value and R is to be considered as a last array index value. Now here you can compare the first array index value with the last array index value. When the first array index value is less than to the last array index value, then we need to find the mid element of an array. So we can find the mid element of an array simply adding the first element of an index value and the last array index value by 2. So we will get the mid element. Once we can find the middle element, we need to divide the given array into two two number of subpods. Two number of subpods. So after the array is to be divided into two number of subpods, and we need to change the locations or places of P, Q, and R. So here A is an array, P is the first array index value, and Q is last array index value. So here we need to apply a process as merge sort. That means that here if you divide or if you break down the given array into two number of subparts, the first sub array is considered as P, and last sub array, the last element in the array is Q. So A to Q. So array, we can sort the elements initially at the left sub array. Later on, we need to sort the elements at the right side sub array. So this statement deals with sort the left side sub array elements. The left side sub array elements starting from P and ending with Q. So starting from here and ending with 7. So we need to sort these four array elements initially at the left half of the array, sub array. So once this list is to be sorted, and again we need to sort Q plus 1 to R. Q plus 1 is nothing but that is considered as a right side sub array. Right side sub array we need to sort here. Q plus 1 is 1 here, and we can move to the last element here. So here the merge sort of A comma P comma Q statement deals with sort the left side sub array, whereas merge sort of A comma Q plus 1 comma R. This instruction they discuss about sort the right side of the array, sub array. Once the left side of sub array is to be sorted and the right side of sub array is to be sorted, then we need to apply a combine concept. That means merge it. We need to merge these two left side arrays, sub arrays. When we apply merge to the remaining two sub arrays, we will get the final output. So here we need to sort the elements from P, Q, and R. That means that the entire array elements are to be sorted, and we will get the resultant array. Resultant array. So in the resultant array, all the elements are to be in the sorted order. In the sorted order. In this way, we can solve the merge sort algorithm by using the principle of divide and conquer algorithm design technique. So here, let us discuss the algorithm with a simple example. Consider an array. The array size is 8. The size of an array is 8. The first element in the array index is to be considered as a P, and the last array index element is to be considered as R. And if you feel the given array is a complex array, we need to split the we need to find the middle element and split the array into two sub equal number of arrays. So here Q is to be considered as the middle element. Once we need to find the middle element, using the middle element, we need to divide the given array into two subparts. This is the left side sub array. This is considered the right side sub array. And again, we can consider this is the complex problem. Apply, divide, and conquer. Find the middle element of the given array. Split the array into two sub-arrays. And again, we can consider these two are complex problems. And again, we can apply divide and conquer principle. Given array is to be split into two sub-arrays. So once the given array is to be divided into sub-arrays, so we need to solve the array elements individually or recursively. Once we need to solve the array elements individually, we need to apply another technique is merge. we need to merge it or combine it, and finally the elements are to be sorted, and we will get the result in this. Here, all the elements are sorted in the given array by using the divide and conquer technique. So initially, we need to solve the problem recursively at the left side part. Later on, we need to solve the problem at the right side part, and finally we will combine left side subarray, right side subarray. Finally, we will get the result at merge sort elements. Okay, friends, in this way we can solve the merge sort elements. Now let us discuss. Now let me explain one more example how to solve merge sort using divide and conquer. We will see. So this is one of the important example. Consider an array. The size of an array is 9. The size of an array is 9. So in the given array, the elements are placed in random order, in randomized order. The elements are not placed in a sorted order. The main objective of the given problem is sort the elements in the given array in ascending order by using divide and conquer algorithm technique. So now we will see the procedure how to solve the given array elements by using divide and conquer technique. We will discuss in this session. So the first step is, if you consider the given array is a complex array, then we need to divide the given array into two number of sub-arrays. And initially we need to find the first element and the last element and find the mid element. Here, the given array is to be divided into two number of sub-arrays. This is considered as a left side sub-array, and this is to be considered as the right side sub-array. So on what basis we will divide the array into two subparts is find the mid value. Here the mid value is 58. The mid value is 58. So hence we need to find the array size is 9 and 4 elements at the right side and 5 elements at the right side. This we can divide. And again we can apply the division method to the given array. So when we apply the division method to the given to the generated sub arrays, the array will be like this only. And two more sub arrays are to be generated from the this array, and these two will be generated from this array. And again we can apply divide to the given array. The two elements are to be split into individual elements here, and 99 6. Here, this array is to be split into two sub-arrays. Here, this array is to be divided into two sub-arrays. And here also, there are three elements in the array. And the array is to be divided into two sub-arrays. And there is a possibility of dividing this array once again and apply divide for this array. So then we will get splitted elements. And here, there is no possibility of dividing the array into some number of sub-arrays. So once the array is to be divided into individual elements, we can provide or we can provide the solution to the individual elements. Here, the division part is over. Once the division part is over, then only we can apply conquer part. Conquer part in the sense we need to sort the elements. And once the elements are sorted, then we go for applying combine. Combine means merge the elements from low to high. So once again I will explain. This is the given array. The array is complex array. When we apply divide and conquer technique, the given array is to be split into two number of subparts. One is left part and the other one is right subarray. So again feel that this is the complex problem. Apply divide and conquer technique. Divide if you apply the divide method to the given array, it is to be split it into two subhalves, and again apply the same till all the elements are to be divided into individual elements. Now it is the time to apply conquer and merge or combine methods to the given problem. Now we will apply the conquer technique, how to conquer and how to merge the elements we will see. So now here we will merge these two. So once we will merge these two, the elements are sorted and then merged here. These two are individual elements, but these two elements are not in the sorted order. When we apply conquer, these two elements are to be sorted, and these two elements, once the elements are to be sorted, then we can apply for merge. The elements are merged into a single array. And again, we can apply the same technique to the all the remaining elements also. So if we apply the same thing to the given elements, so here these two arrays are to be combined and the elements are to be merged. And these two elements are to be merged here, we will get the resultant array. These two individual elements are merged, we will get the resultant. So next one, we can continue the same process. We can combine these two sub-arrays. The elements are to in the given array are in the sorted order, and we need to combine these two arrays. Elements are to be sorted. And again, we need to combine this left side subarray and right side subarray. We will get all the elements will be stored here, and the elements which are stored in the given array are sorted order. So here in this way, we can sort the given elements by using divide and conquer. If you consider the given array, all the elements in the array are sorted, and we will get the resultant. Friends, in this way, we can solve the divide and merge sort problem by using divide and conquer algorithm design technique. So as of now, we will discuss how to write an algorithm and how to solve merge sort with an example. Now let us see how to analyze a merge sort problem. So analysis, how to analyze merge sort. Here we can analyze the merge sort means how to find the time complexity and space complexity, we will see. So this is considered, this is an algorithm, merge sort an algorithm. Algorithm, name of the algorithm is merge sort, and here we are passing two parameters. One is array, and L is the first array index value, and H is the last array index value. If first array index value is less than to the last array index value, we need to calculate the mid value. So the mid value is to be calculated as follows: first array index value plus last array index value by 2. Once the mid value is to be found, this is the time to divide the given array into two number of subparts. So how we can divide the array into two subparts means, so L is the first element and H is the last array index value, and in between there is a mid. And when we divide the given array into two subparts, and we can say that there are two ways we can divide. The first one is the first array index to the middle value, and the second array is mid plus 1 to the last array index value. So this is the left. This statement is to be considered as left side subarray, and this is considered as the right side subarray. So we need to apply sort. We need to sort the left side subarray elements. Once the elements are sorted, then we go for applying merge sort to the right side subarrays. Once left side subarray elements and right side subarray elements are to be sorted, then we need to go for combine and conquer it, merging it. So when we go for merging the elements, we can apply the same from first array value to the last array value, and meanwhile we'll get the middle value also. So in this way, we can write the algorithm. So whenever you are planning to calculate the time complexity of an algorithm, first write an algorithm, Next one, we need to find how many times each and every instruction of an algorithm is to be executed. Now we need to calculate how many times each and every line of instruction in the given algorithm is to be calculated. Here, this is to be calculated, the header part of an algorithm. um, the header part of an algorithm took zero time complexity, and here this statement also took zero statement, zero time complexity, and here we need to find the mid value, the time complexity. Whenever you have to calculate for this, it will the statement is to be executed only one time. So we need to find the mid element only once in each array. So the then we go for applying merge sort. How many times we need to go for merge sort is here. The complex problem is to be divided into sub problem. Then only given problem is T of n. When we divide the given problem into two sub parts, then only the complexity is T of n by 2. And this will also take it n by 2 times. Division can be carried out n by 2. Consider TFN is the problem, and this merge sort will be considered as a TFN by 2. And the merging, so merge sort will do n by 2 times, whereas merging will consider as a n times. This statement is to be executed n times, and the sorting left sub array, right sub array will do n by 2 times. And we need to sum all the how this T of n by 2 plus T of n by 2 plus n. 2 into T of n by 2 plus n. So this is to be considered as a recurrence relation. This expression is to be considered as a recurrence relation. So when this recurrence relation is to be true, when the array can contains more than one element. If an array can contains more than one elements in that, then the recurrence relation generated for the given array is 2 into T of n by 2 plus n. When the array can contains only one element in the array, in this case, the time complexity of an array is simply 1. So this is the recurrence relation. When we can solve the recurrence relation recursively, we will get the time complexity of the merge sort is order of n log n, theta of n log n. So the time complexity of merge sort is theta of n log n. Friends, this is very important. You may get one question in examinations, analyze the time complexity of merge sort. It's very simple. So whenever you are planning to write or solve the time complexity of any algorithm, the first step is write the algorithm step by step procedure way. Once the algorithm is written, and calculate how many number of times each and every line of the algorithm is to be executed. Here, this line is to be executed one time. This statement is to be executed T of n by 2 times. This statement is to be executed T of n by 2 times. This statement is to be executed n number of times. So after that we can sum it, and we will get the resultant value. Now here we will see another way of calculating or analyzing the time complexity of the merge sort. In the merge sort, initially we divide the array into two equal subparts and solve them recursively using merge sort. So here T of n by 2 L means left side sub array. That means that the given array is T of n. When the given array T of n is to be divided into two parts, one is left part array, another one is right side sub part of an array. In this case, here the formula is T of n by 2. N is to be divided into two parts. So T of n by 2, this is the left side sub array, and this is the right side sub array, and totally the time complexity is 2 into T of n by 2. So left side sub array is NL, whereas right side subarray is NR, and these both are equals size subarrays. So finally, once the array is to be divided into two number of subarms, we go for merging these two subarrays by using the merge sort procedure. It will take to merge the two subarrays. The time complexity is order of n. So, whenever you are planning to merge two subarrays, so the time complexity is order of n. So if T of n is the time required by merge sort for sorting an array of size n, then the recurrence relation for time complexity of merge sort is. So friends, so there is a procedure to analyze the time complexity. The time complexity can be analyzed by using recurrence relation. So here, this formula is to be considered as a recurrence relation. How you will get this recurrence relation is, we can get this recurrence relation through algorithm only. How many number of times each and every statement in the given algorithm is to be executed, this statement is to be clearly indicates. So here, T into T of n by 2 plus order of n. So this is nothing but left side subarray execution time plus right side subarray compile and execution time, and the order of n is considered as the merging. So this is division part, this is merging part. That means that here we are combining division type complexity and merging type complexity. We will get the total type complexity of merge sort. On solving the recurrence relation, we will get the time complexity is order of n into log n. So the time complexity of merge sort is considered as order of n log n in all cases. So if you consider the time complexity of merge sort, it will be constant in all three cases, like best case, worst case, and average case. And while calculating the space complexity of merge sort, we need to consider the formula is how to calculate the space complexity is equal to constant space plus variable space. Here, there is no constant space, it is a variable space. Why? Because we need to merge the elements into n number of times, and we need to divide the elements into n number of times, and we need to convert the elements into n number of times. So the space complexity of time complexity, the space complexity of merge sort is order of n. Now here the question is, which sorting technique is better? Quick sort is better, merge sort is better. Friends, which sort technique is better? Quick sort is better or merge sort is better? So now let me clarify here. Merge sort is more efficient. Merge sort is more efficient and works faster. When merge sort is more efficient and it will works faster than the quick sort is if the size of an array is large. If the array size is very large, merge sort performance is better than quick sort. When it is applicable is the size of an array is very large. If the size of an array is very small, quick sort is more efficient than merge sort. So this is a important question. Now we will discuss another example how to solve merge sort problem using divide and conquer with C. Solve merge sort using divide and conquer approach. Here consider an array A. The array can contain list of elements. Verify that all the elements in the array are in which order. Consider the given array, the elements which are located in the given array are not in the sorted order. Now we need to apply divide and conquer technique to sort these elements in the array. So if we feel or consider this is the array elements are to be placed in an place. We feel that this is the complex problem. When we apply divide and conquer technique, the given array is to be divided into two parts. So this is left sub array, this is considered as right sub array. And again divide this array into two subparts, left side subarray, right side subarray. And again divide this into two subparts, left side subarray, right side subarray. And there is no provision to divide this array into two subarrays. Why? Because the array can contain only one element. When the array can contain only one element, and further when you do not divide the array into two subparts, you simply stop division. Once division stops, then you can apply conquer and combine method. So when we apply conquer and combine method, the elements are to be sorted and then combined. Here, the elements in two subarrays are sorted and then combined. So again, we can apply the same to these two subarrays. The elements are sorted and combined. Continue the same process till all the elements in the given array are to be sorted or not. So initially, we can apply this divide and conquer technique to the left side subarray. Later on, we can apply the same thing for the right side subarray. So after that, and finally, we need to combine the left side subarray and right side subarray, conquer and combine when we apply the concept. The elements are in the sorted order. So friends, in this way, we can sort the elements in the given array using divide and conquer technique. Thank you. Thank you so much.